Swayam Prabha. Digital India. Educated India.
Now comes the part where you will really become an inventor. What I would do is what is called first principles thinking. I'm going to lecture about it separately later, where you go down to the basic understanding. What's the basic understanding? If the force easier to cut, and the reverse of it. Okay. And what matters is force per unit area. What matters is material. Right? Two basic facts and understanding I have. Now I can be a good inventor and idea producer. I can ideate very well because I am starting from basic facts of understanding. And therefore, what shall I do over here? There are only two things that I can change. Decrease the force and fantastic. How do I decrease the force? Come.
Remove the windshield. So he's going to
Okay. Okay. So he's holding his hand. This is the crack. Right? What shall I do? Apply a force. Correct? If I apply a force like this, it will. If I apply a force like this, right? So how shall I do this?
put magnets there. Put magnets there.
Put magnet there. Very good. Thank you. Put magnet there. Glue it. Put some. Wait. Huh?
So we can remove all the air molecules that we discussed in our lab.
Stick two things. You pull and stick. Correct?
Yes, sir.
All these are to do with force. We also have area. What shall we do? Shall we increase area or decrease area? Increase area. How shall I increase the area? And add one more
Volume.
piece. Very good. What else? Remember, you
Sir, do you
have
want to do
experience of tearing.
Sir, would you like heat it somewhere in the middle so it somewhat settles, like the volume is greater?
How is it related to the first principle?
Because why not, sir? You're
That's the
increasing the
question.
area down.
See, when an inventor starts, they are like scientists, right? We go down to the level of deeper understanding, use that in order to invent. That's why you see a lot of scientists inventing. The reason is that they are going to the depth. So we are going to the, we have already gone to a certain depth, which is I know force, I know area matters, I know material matters. With this, I want to now come up with whatever you came up with. You came up with gluing, right? Putting an additional force in some way, and then you said you add some another layer, do a sticking to the two parts of it. What else?
Make the crack bigger and remove parts of it.
Wonderful, yeah. I mean, give him a hand. All you need to do is at the edge now, you just make it bigger. Just like your first sheet. The first sheet was such that you could not tear because there was very little scope for that. The area was larger and therefore you could not tear. Is this clear? And therefore the mechanic did exactly that. Mechanic came up with a beautiful idea of putting a small hole at the tip of this crack. Enough. It didn't propagate. Idea emanated from and understanding. And therefore, folks, F for fun. Fun? No fun. O for can't hear you. U for
Understanding.
D for
Discovery.
N for notice. Very good. So, folks, you can use this for everything. What did we do? We focused on the middle, which is you, understanding. How did we understand? We brought it down to a depth which was clearer for us to invent many things. Now, if you go back to every one of those where you notice, no, people looked at this in order to come up with an answer, right? Not necessarily they have to be educated. As long as they are able to understand that there is a force necessary, there is an idea necessary. Beautiful, no? So, will you forget this in your life? You will not forget this in your life. And therefore, when I went the other day looking for a flat to buy, I went and I saw a small crack there. Will I buy that flat? Why not? Crack in my pocket, or I'll ask them to fix the crack before I buy it. And therefore, it is very useful for me in order to do so many things, including solving some of those problems, the daily life problems. How many of you have seen, most of you wouldn't have, anybody from a defense employee? Oh, okay. Have you seen a bomb?
Wow, no. I might have. I don't remember.
The shell.
Yeah,
Yeah. The shell actually has a small this pin,
Pin,
has
yeah.
to be pulled
Yeah.
out. Right? That pulling out had to do with I should have enough force, but the force should not be very small. Right? I have to have the right way by which it has to break, and the bomb when it has to explode, if there is a small crack, the bomb is not of use at all. Just like it was so easy for you to tear the sheet. There, what they make sure is when they make this, it is integral completely. The strength is enough, packed within in such a way that when it explodes, there is a suddenness to it. Okay? We'll stop here for the next game. You can go have water and come back and sit. How about that?
So, what was this for?
Yeah, and please, what will you do with the torn plastic sheets and all those? You throw it around?
What about? So do we need to
Put it in your pocket first and then later.
So do we need?
10, 16 now, 10, 18 will be back.
So do you want us to keep the paper?
Yeah, white sheet, you keep it. I'll come back to it later.
We can't.
Freeze!
No.
Freeze. Somebody has gone for fire break. Okay. We were talking about discovering, right? One other person came up with this.
Yeah. Yes, sir. I was.
Here it's easy for me to tell anytime. Of course, this doesn't have the strength that the other cellotape has along the length. But this is one other solution that is possible. It's not like a back to the chapter problem where you have one solution and that's it. In daily life, we have lots of solutions possible. Right? Okay. So, before we move on to the next one, if I take a balloon, how many of you are afraid of?
Oh yeah.
Anybody who wants to help me with breaking?
Oh my god. Oh my god. You.
Yeah, okay. Now, challenge her as to what to do, what not to do.
Don't break the balloon. Don't put it in without breaking. Put the needle in without breaking the balloon. Put the needle in without popping the balloon.
Put the needle, but it shouldn't break. She's going to now do exactly what. Look at that.
Masking tape. Use masking tape. Sir, use masking tape.
You didn't tell that she shouldn't use tape.
No,
Thank you.
It's deflating.
Okay. Now, this is the chocolate question. If there is a way by which you do the same thing, but not through this thing. But yeah, wait. Before you come, you have to tell me what you are going to do, how you are going to do. All right? Yeah? Yeah, go ahead.
I can tell you now.
No, tell what you are going to do.
Okay, fine. There are two membranes, the upper and the lower one.
Which should not happen.
The thicker parts. If you pierce the needle there,
Ah.
it won't burst.
Why not? You're done now. See, I have to think scientifically now. It has lesser tension than the other. So when I prick here, what happens? I'm going to break. Okay, I've already put it inside.
So can you leave it inside?
We take it away.
The reason is, like what you said, or in other words,
Difficult to produce a crack. It's difficult to produce a crack.
force was less. Doesn't
Area is
matter.
more.
What's the
Therefore,
same?
Area is more.
And
Area
here,
is more, so force
Yeah.
is the same essentially.
Area is more. Here area is less.
I increase the area.
Area is more.
Alright?
That area is less, but you used to be.
Can I pierce this balloon?
Yes.
Why not? Why and why not?
You can.
Now you are talking because now you have an understanding. You have used that understanding and said what would happen, which means that it is also possible for us when we understand things, we can predict what will happen and therefore prepare ourselves. Correct? Right? Many are predicting that there may be war between Pakistan and India. I hope not. But that's basically what it is. Okay, so let's go to the next game. Ready?
Yes.
Huh?
Yes, sir.
Alright. Okay, before that, we had some fun activity, observed, understood, noticed. Alright. Will you remember this all the time? And remember, every one of those things that you do, it is possible for you to have fun, understand, notice, and even discover. Suddenly you will become inventors after the inventors. Okay? By the way, that's my experience too, by the way. I have to tell you this. By understanding, there was a lot that I could contribute to in terms of ideating and solving. Okay? There was water scarcity in highlands. What is highland? Tell me. Himalayan range, correct? And the people of highlands faced water shortage. Surprising, but that was what it was. Especially during some spring and summer months, where the water that flowed from the glaciers were thin. Okay? I don't know how many of you have gone to Ladakh, Leh, Ladakh, yeah, a couple of you. The region there usually uses glacial melt water for irrigation, etc., etc. right, for livelihood, irrigation and so on. But there was limitation in terms of storing water. One may ask, why can't I just dig a well? Why can't I just dig a pond, right? And water will get filled up. Unfortunately, that land is a very porous land. Water would just seep into it. Aquifer will get formed, right? And therefore it is not possible for us to store water that way. One may say, okay, I can probably get a tank. How many tanks? There are so many people. How can I now take care of such a possibility? And therefore, whenever I have to store water, without having that tank, the water will seep into the ground, and the ground water is also not going to be enriched because it will go down to the valley. Is this clear?
Yes.
And therefore, they were suffering. I'm not talking about one village, two villages, 300 villages were suffering because of this. And therefore, it was not possible for them to live in those villages for those part of spring and summer months. They had to come down to the valley in order to have a livelihood. Think of it. You have not stepped out of home. You don't know how difficult it is to be away from home. Right? When you ask us, because I'm too old for this, but if you ask college students, they will tell you, oh my God, now I'm in the hostel, so many things have to be taken care of, etc. But they had to do that. They had to live in a tent. Right? They had to work for somebody else to get their livelihood on. Right? Else, they would have starvation. This is what was happening. We don't know. Right.
The backup mic இருக்கு.
Now it's okay?
Yeah.
Okay, so people wanted to find out how to store water. I already told you about the reasons. There could be dams as another possibility. Again, if I build dams, same problem will occur, which is seeping underneath, right? So, complete possibility of having water stored in any manner of that sort, which is usually done in normal places, they could not do. But I need to store water.
So probably the government can raise up funds and make an underwater pipelines from the valley to the people there.
Right, so anything that we could think of were very expensive.
So what about storing water in the winter as like to freeze it as part of the glacier so that you can use them again as they melt in the summer?
Very good. Or in other words, now you are starting to think, okay, I can't store water. So think of how you will come up with these ideas here.
Sir, you can't store water in wells and stuff because they're porous, right? So we
One way is
No,
to make it impervious.
by
But making it impervious is very expensive.
no sir, you can use plastic waste, you clean it, put it together as a sheet and like put it inside, sir. Best from waste
Yeah, good,
and
But-
cheap.
good. Try it out.
Okay, I will.
But it's a good idea that you're coming up with because you're now looking at a layer which is impervious.
Yeah.
Right? So that the flow does not happen. So what he is now thinking is, okay, flow should not occur. Subsurface flow should not occur. What should I do? Okay, I can probably put something which is a layer which is impervious. Fantastic thought. You were going to say something. Yeah. And he also came up with something. Yeah.
So taking advantage of the porous soil to construct underwater reservoirs and things.
Underwater reservoir
Underground
will happen at the valley. You understood? Because the water would just seep into the valley directly. Because I don't know, if you have gone to Ladakh, you will understand this. Your legs will become quite muddy. Very fine soil. Very difficult to store water for a long time.
What about a plastic freeze the
So
roots.
we'll come to that. So we'll go from a way of understanding the whole thing. I don't want flow to occur. Basic understanding?
Yes, sir.
Yeah? We'll come to ideas later. But our understanding is flow of water is the main problem. Right? Can I now build from that understanding that I should not let flow occur? One of the ways he said is impervious layer on top. But it's very expensive. That's a solution that can be thought of if we are wealthy enough to do it. What other ways can I now think of avoiding flow of water?
So water flows only when it's in a liquid state. So when we can just freeze the water and store it.
Wonderful, yeah. This guy comes up with ideas like that. He also said the same thing. Basically, what if we make, so I'm going to translate it this way. What if we can make water into something that does not flow? Right? Immediately what came up, both of you, okay? Don't get too tied up with this. But the important point here is, I'm now thinking, okay, can I now stop the flow? One way is impervious layer, etc., etc. The other is water itself. Now I can change to some other state. That's what these two guys have come up with. What state? Now, it's very expensive to freeze ice in Chennai.
Yeah,
But there it is not difficult, right? So now I have one more idea where the temperature should be suitable for me to be able to do this. This is the thought that went on in the mind of one single person, not everybody, one single person. Why not solidify water and store? Does the physics allow it? That's the question. Well, the answer has 2 pointers, which is it is a cold place. Sub-zero temperatures are possible. The second one is water in its solid state will not flow. Two are clear now? Yeah? So this guy combined these two, right? And came up with something. Not biryani. Do you know what that was?
Biryani is out-watering. So you just let your
So a guy by name Sonam
Sonam Wangchuk.
Wangchuk. Sonam Wangchuk. How do you know?
I've read.
Three Idiots.
Right, yeah, that too.
Sonam Wangchuk thought differently, like these two fellows. Why not solidify water? And use the solidified water in order to help ourselves during summer and end of spring. Summer is hotter, correct? And therefore it will melt. I'm not done yet. I'm going to come back to this question again. Solid water is not going to remain solid in summer because it's going to be hot, correct? So we have to solve that problem also. So hold on to that flag, alright? Not right now. Hold on to that flag, we'll come back to it. Okay? Are you ready for the next point? You go to a restaurant, biryani is hot, mouth-watering, but it's very hot. What would you do?
No, no sir.
Huh?
Increase.
Why blow?
Spread it out, sir.
Huh? To fasten the process of cooling. What happens there?
The heart rate increases faster.
What happens there?
Steam
How many of you
escapes
can
fast.
give a very nice explanation?
So sir, first you spread the biryani out. When you
Wait,
spread
wait,
the
wait, wait.
biryani out,
I'm not only talking about blowing.
oh, blowing. Okay. So when you blow, basically what happens is the air in your mouth, you condense it, like you condense it, and when you blow it out, like the water it
Too much
gets.
explanation, no?
So
Teacher,
easy.
teacher, wait, teacher.
I think I might have simple explanation. So when you have biryani, it gives away the heat the air molecules. So the more the number of air molecules that hit the biryani, the more the heat will transfer away. So when you blow,
Too much now. He's going to be tomorrow's scientist, yeah.
When you blow it, the hot air goes away and the cool air comes and
Not bad. So, the air that I blow, is it hot or cold? Comparatively cold. And therefore, what would happen?
The hot air is less dense, so
Like what he said, the momentum is transferred from this to this, etc., etc., etc. We'll come to that later. But the fact of the matter is, it will just take away the heat, and the fresh air will occupy that space, right? And therefore, it may cool down. But how many times can I blow? Blow. It is tough. So what would I do? Spread it out. Very good. All right. You spread it out on the plate. This is what you do. On the other hand, I am a waiter. I am a waiter. I have to make sure that I serve biryani hot. What should I do? It's the same biryani.
Cover it.
Very good. Shall we now go to first principles?
Yes, sir.
Wait, yeah. Don't be in a hurry, yeah. Have you read Think Fast and Slow? People who think fast always make mistakes. Think slow whenever it is necessary. Right? So, in my family, I am the slowest. Okay, but coming back to this. What is it that is responsible is a question that we ask, correct? Yeah. Don't raise your hand. All of us know. Don't worry about it. Spreading is one way of cooling it. Heaping is one way of retaining the heat. Right? So there must be a difference between the heaping and the spreading. And what is it? Surface area. Correct? All of us know it. Right? All of us know it, that it is a surface area that matters. Right? Surface area gives scope for more interaction to happen with the air, and therefore it is possible for it to. And therefore surface area seems to matter a lot. So far so good. Is this clear? Right? That's what the waiter does. Very simple. All of us understood this. I have a single block of ice on one side and 8 cubic blocks of ice of same volume on the other side. Each small cubic block is 1 foot long. What is total surface area of the 8 cubic blocks and that of the single block? What is the total surface area? Surface area of the 8 cubic blocks and chocolate. Quickly. Now we can do fast thinking. What is the surface area of these small cubic blocks?
Sir, it's more than
Total surface area of small. See, on one side I
for
have
8 blocks. It's more than.
What is the surface area?
This.
48 and single. Tell me no number here. Huh? 24 and?
24 and 48.
Okay, you both will share 48 and 24. Which is 24?
24 is one block.
One block. Okay, supposing it has to melt fast, you have to give half to that. Yarad Mogini. Okay. Alright. Now, which one will melt fast?
8 blocks.
Clear, no? Very simple. Just like biryani example. Right? Don't let your mouth water now. This is very simple. Understood. Now I'm going to go to a story. All of you are from Chennai, correct? No. Some of you would have probably shifted to Chennai. How many of all of you are not from Chennai? Anybody who is not from Chennai? Who studies somewhere else? Where? Oh, Bangalore, okay. So we're going to tell you a story about Chennai Ice House. I lived in this place for, not the ice house per se, but nearby. I lived there all my young days. Ramanujam also was living, but not during my time. But coming back to this, when they said it is ice house, I thought these crazy Englishmen, no, name themselves very, very differently. Spring water, little wood, right? So I thought, okay, this guy's name is Ice and his house is Ice House. Till my uncle came and told me, do you know ice was stored over here? When there was no fridge available in this world. So, Mama, how can that happen? It will just melt away. He said, yes, it will melt away. They had all those ways by which the melted water would go to the ocean. Then what's the point? Was my question. And he gave a beautiful story. He said, huge icebergs nearer to Britain would be hauled all the way to Chennai, and this would be kept in ice house because these Englishmen loved hard drinks. H-A-R-D.
Soft.
Right? And they wanted ice for that. Got it? Is this clear? So I was wondering, how does it matter if it is iceberg, etc., etc.? And he gave me this biryani example. He wanted to know why it happened. It was clear to me at that time, oh my God, surface area. Surface area of a huge block was lesser. Right? What's the name? Huh? Moni. For small blocks, the surface area was less. More, right? And therefore, if I haul a huge block, the surface area would be less, and therefore the scope for it to melt was lower. So now Mamchuk said, okay, can I make iceberg-like structure over there in Ladakh? The result was he made so many ice stupas. All he had to do is let water go up a height, let's say 8 to 10 story building height, and spray. As it sprayed, it became ice like a snowfall and started to fill. Right? And it formed a huge stupa like this. The surface area of this was very less compared to the volume. And therefore, his idea clicked. Today, all those 300 village people worship him.
Yeah.
Right? Actually, he stood for election, he could not win though. But that's what it is. Simple idea, very, very simple idea. And it won him this. Alright? Every one of us is capable of not only ideating, becoming an inventor. It is just that we need to stick to that, find out how to do it. What do we stick to it? What do we stick to? The basic principles. And to be able to build it. When we are able to do that, we will strike at the solutions. One of our students, Rahul Panikar, when he went and started doing design, he came up with an idea that won him laurels. Okay? I'm going to tell you about that idea. Okay? I'll leave this. And that was to do with the electricity free incubators. Okay? What did he do? Well, before I tell you what it is, there are so many problems associated with incubators. Incubators are necessary for premature babies, right? And for a length of about 2 to 3 months or even greater, you need to make sure that the temperatures are kept within the range that we have body temperature. Else the baby would die. The main reason is it does not have the capacity to regulate body temperature. But in villages, it is not possible to have such incubators, the reason being very expensive. Not only that, you all would have heard what happens in villages, they only get electrical power. It's not like places like Chennai, right? So you can't depend on electricity. And therefore they had to come up with some design where there's completely electric-free incubators that they should come up with, by which it is possible for helping those in the rural areas. Clear about it? Watch this video, it's a beautiful video. When she says something, you should do it, okay? Alright? Yeah? Okay. Oops. Can't hear. His name is Rahul Panikkar. He is now into AI products. Jane Chen and Rahul Panikkar came up with this. The idea is very simple. What happens when ice melts to become water? Temperature remains constant and there is latent heat, correct? They just use that principle to come up with a product. Wonderful product. That's what I want you to want you to watch this.
Please close your eyes and open your hands. Now imagine what you could place in your hands. An apple, maybe your wallet. Now open your eyes. What about a life? What you see here is a premature baby. He looks like he's resting peacefully, but in fact he's struggling to stay alive because he can't regulate his own body temperature. This baby is so tiny he doesn't have enough fat on his body to stay warm. Sadly, 20 million babies like this are born every year around the world. 4 million of these babies die annually. But the bigger problem is that the ones who do survive grow up with severe long-term health problems. The reason is because in the first month of a baby's life, its only job is to grow. If it's battling hypothermia, its organs can't develop normally, resulting in a range of health problems from diabetes to heart disease to low IQ. Imagine, many of these problems could be prevented if these babies were just kept warm. That is the primary function of an incubator. But traditional incubators require electricity and cost up to $20,000, so you're not going to find them in rural areas of developing countries. As a result, parents resort to local solutions like tying hot water bottles around their babies' bodies or placing them under light bulbs like the ones you see here, methods that are both ineffective and unsafe. I've seen this firsthand over and over again. On one of my first trips to India, I met this young woman, Savita, who had just given birth to a tiny premature baby, Rani. She took her baby to the nearest village clinic, and the doctor advised her to take Rani to a city hospital so she could be placed in an incubator. But that hospital was over 4 hours away, and Savita didn't have the means to get there. So her baby died. Inspired by this story and dozens of other similar stories like this, my team and I realized what was needed was a local solution, something that could work without electricity, that was simple enough for a mother or a midwife to use, given that the majority of births still take place in the home. We needed something that was portable, something that could be sterilized and reused across multiple babies. and something ultra low cost compared to the $20,000 that an incubator in the US costs. So this is what we came up with. What you see here looks nothing like an incubator. It looks like a small sleeping bag for a baby. You can open it up completely. It's waterproof. There's no seams inside, so you can sterilize it very easily. But the magic is in this pouch of wax. This is a phase change material. It's a wax-like substance with a melting point of human body temperature, 37 degrees Celsius. You can melt this simply using hot water, and then when it melts, it's able to maintain one constant temperature for 4 to 6 hours at a time, after which you simply reheat the pouch. So you then place it into this little pocket back here, and it creates a warm microenvironment for the baby. Looks simple, but we've reiterated this dozens of times by going into the field to talk to doctors, moms, and clinicians to ensure that this really meets the needs of the local communities. We plan to launch this product in India in 2010, and the target price point will be $25, less than 0.1% of the cost of a traditional incubator. Over the next 5 years, we hope to save the lives of almost 1 million babies, but the longer-term social impact is a reduction in population growth. This seems counterintuitive, but turns out that as infant mortality is reduced, population sizes also decrease because parents don't need to anticipate that their babies are going to die. We hope that the Embrace Infant Warmer and other simple innovations like this represent a new trend for the future of technology. Simple, localized, affordable solutions that have the potential to make huge social impact. In designing this, we followed a few basic principles. We really try to understand the end user, in this case, people like Savita. We try to understand the root of the problem rather than being biased by what already exists. And then we thought of the most simple solution we could to address this problem. In doing this, I believe we can truly bring technology to the masses, and we can save millions of lives through the simple warmth of an embrace.
Fantastic, no? How many of you did not know this idea? How many of you did not know this fact about latent heat? Look at that. The latent heat idea was there in your book. You learned it. But that's not enough. I should be able to apply it to things. How do I do that? So the next few exercises that we do. So the next few exercises that we do, or the games that we play, will be related to helping ourselves come up with habits that will help invent like this. You ready? Yeah. So we have to wind up at 11 o'clock, 11:05. Right? So 10 more minutes to go. We'll play one game?
Yes.
Sweet.
See, by the way, this is the most important thing, right? That temperature remains same over a period. Why? Because all the heat energy is being used, right? So you're ready to be first principle thinkers? Yeah? First principle thinkers will first go down to first principle. So this is called basic concepts gym. Okay? So we go exercise in the gym. Product to scientific principle. Very simple. So what I'm going to do is I'm going to show you some product. You will tell me this is scientific principle behind it. Are you ready?
Yes, sir.
Yeah, let's see how we perform. The last time they performed tremendously fast. Magnifying glass. Refraction. Wonderful. Yeah, okay. You like?
Sir, ionization.
Desert water cooler.
Desert water.
Oh, that's latent.
Desert water cooler. Fast.
Heat transfer.
Okay. Mirror.
Reflection.
Fountain pen.
Capillary.
Hand fan.
Convection.
Handheld fan. Handheld fan. Convection, correct. Yeah, who said that? Yeah. Hot water heat pack. Matchsticks. Wow. Sweating. Dish sponge. Thermos flask. Charcoal for water filtration. Walking. Actually falling. Dew on grass. Touch screen. Naphthalene. Heat element. Metal detector. Remember, this is a rapid round. Optical fiber.
Refraction.
Glue. Weak bond. Boats. Oven mitts. Oops. What is this? Okay, good. Humidifier.
What's your
Humidifier. Of course. People don't know unless you are in Bangalore. Not that much, okay. Rocket. Solar cooker. Cylinder pressure. I'm going rapid fire. Rapid fire. Super rapid fire. Kaleidoscope. Multiple reflection. Sonar detector.
sound wave?
Electric fuse. No, electric fuse. Resistive heating. Very good. Whistle. Vibration of air power. Very good. Chalk piece. Another word for it. Electric bell. Solenoid. Lactometer. Thermometer. Jet engine. Pinhole camera. Calorimeter. Calorimeter. Telescope. Stethoscope.
Reflection of sound.
Reflections of
Vibration. And air column vibration. Hot air balloon.
Conduction.
Very good. Pressure cooker. PV equals. See that you're very familiar. Door handle.
Magnetic field lines.
Hydrophobic and
Okay. Biogas plant.
Decomposition.
Okay. So time is short, else you could play this as a group also. Right? You can mention some product, the others can find what the scientific principle could be. If you cannot find as a group, what will you do?
Ask you.
Google. Right now, no more Google. You do all right. So this is what you do basically. You can do it anytime. Even if you are alone, it's okay. You just think of a product, find out what could be the scientific. But remember what happens to you. When I showed the product, immediately you came up with scientific principles. That's very good. That's a good starting point. Because that's what happened to every one of them. Whether it was Sonam Wangchuk or Rahul Panikkar, and we call him RP. This invention, no, they could save 200,000 premature babies. And then UN has now adopted it so that every village could be benefited, supplied with this.
It is still in India.
Hmm?
Because I never heard of it. It's still in India.
Yeah. So, if you go to all those healthcare centers in the villages, they have supplied, UN has supplied enough material. Five more minutes, I'm going to now tell you a problem and you're going to come up with a solution. Right? I'm quite old compared to you. Right? So, what happens when you become old?
Joints
What happens when you become old?
You become more wise.
But your organs start to not fail, but not perfect. Right? One of them is eyes. Right? So what I could do when I was young like you, I cannot do today. Now what will I do? I will depend on technology, not you. Because you are tricky. No, dad. Like that, right? So my sons did that. But the point is, I wanted to fix a button in my shirt which had broken, torn off. Wanted to stitch it. I had the needle with me. I had thread with me. But I couldn't thread the needle.
Sir, with proper vision also we are unable to.
Yeah, please. So, I need to thread the needle. I was searching for solutions. One solution that I found was a dispenser which looked like a sort of a square, thin wire where you can insert it, put the needle, because it's a very large area. You could put the needle and then pull it out. And it worked. But the thing is, the next time around when I tried, I had misplaced the dispenser. Very similar to the sellotape, right? Then I was looking at, okay, so there are other suggestions that were given. What could be those suggestions?
Sir,
Go
you
to
put
a
the needle,
tailor.
rub the needle and the thread
Wear
together.
glasses.
You
Even that
rub the
doesn't help
needle and the
anything.
thread together on your hand so that it goes into the needle by itself.
Yeah, I close it in the needle and do this, okay?
Sir, go to the tailor.
Wet the thread. So all those are fine. Is there any other way that I can do it? So I'm going to ask you through an example. Wait. How many of you have seen the strap of your bag with this kind of hook?
What?
Are you able to see? Yeah? You insert the, this is, for ID card you may have that in your, do you have it in your ID card?
Not exactly.
Wonderful, yeah. So you have it like that, correct? Why am I showing this? What's the fun in showing this? Right? Can I use something related to this in order to help this 63-year-old thread the needle? One of the inventors came up with that. Which looked like this. I have the needle sold with me. Whenever you have time, you can come and see. It had something like this and something like this. Something like this. I'm just blowing it up, but this is not that big. All I had to do is run this thread along and it will go inside. I could easily thread it. That fellow is now marketing it. Oldies like me will buy it. Correct? Idea could sell it. Right? So folks, ideas are very powerful. To get ideas, first principles are very powerful. That's what we are learning. We know one thing, which is the scientific principle behind a product. Okay? as we run along with another set of games, we'll learn better. We also learned one more habit. Found. F for? O for? N for?
Notice of application. Notice of application. Notice of application.
D for?
Discovery.
Wonderful. So we'll take a break, come back, play more. Yeah? 4 more games are there. Thank you. Scientific principle, correct? Yeah? I told you a product and you gave me the scientific principle behind it. Product, scientific principle. Now scientific principle, product, how about that? Huh?
Yeah.
Shall we try that? So that we become better at it. Which one is easy? Product to scientific is easy. Because that's what we learn in our lessons. Alright? So let's try the other way. Reverse way. Shall we? All of us are here now? Anybody still from bio break? Very good. Okay. So think products. I'll tell you the scientific principle or the phenomenon. You will tell me products. Okay? You ready? Alright. It's also a gym because you got to exercise. Phenomenon to think product. Ready? Ready.
Water
balloon. Very good. Good. Sea breeze, land breeze. What is it?
Sir,
Igloos.
What is it called here? The roof of the house has chimneys. Very good. Chimneys.
Lanterns, sir. Floating lanterns.
lanterns are essentially just small hot air balloons.
No, yeah. Lanterns is a good example. Very good.
Yeah.
I'm so happy that you're coming up with products. Some more. Windows placed on top of the room or small openings on top. If you go to in villages or huts, no, they would have opening on top, so that the draft of air, which is hot, goes out.
So earthen pot.
Right?
Earthen pot.
Earthen pot is different. It's about evaporation. We are not talking about evaporation here. Yeah. Window ACs are the word. This is actually wrong. Yeah.
So the AC is wrong.
AC position is wrong. It should have been down below, so that the hot air rises up, taken away. It is not happening that way. Go ahead. Actually, ACs cool the walls first, floors first, the ceiling first, before we feel comfortable. But we'll come to that. Just wait for a few minutes.
Sir.
Is there an answer for this?
No.
Just answer for this. We'll come to that later. Any other product? Come on. Hot air balloon is correct. Chimney is correct.
Oh, nuclear reactor.
Cooling tower. So I was telling a group of students about this. The name of the book is Design of Shells by Philip L. Gold. He came up with this wrong design, I corrected it. Then I found this on YouTube.
Oh, it's been.
Nice, no? So in the night you will see that pattern moving around.
Yeah.
Sir, but there's no function.
Shall we go to the next one? Ready? Ready? Okay, black surfaces are good heat absorbers.
Solar
Painting the road black.
So wearing white clothes in summer.
Heat shields are
Wearing white clothes in
craft.
summer. So cricketers wear white clothes in summer when you're playing.
Very good, white clothes in summer.
So wrapping.
So when they saw Israel from above,
It's white.
they saw only white because all the roofs are painted white. Glossy. Yeah, go ahead. Yeah. Products. See, look at how they thought. I can reflect so that it doesn't absorb. Yeah.
Dark blankets.
Dark blankets.
So
For
they
what?
have this thing called black box.
Protection against cold. Okay,
So
very good.
it's like they have microwaves that are black in color to heat the food inside. I don't know what it's called, but like it's used to heat the food. It's black in color using sunlight.
Yeah, it's called solar heater.
You can paint stuff
Solar
black.
stove.
You want to dry quickly, you paint it black. The earliest cars were painted black because it dried faster.
Yeah. So usually cars are painted with something that reflects, right? Yeah.
Black color snow.
Black color snow wear. Yeah, correct. Very good. That's why suits that they wear are black in color. We borrowed. I'll tell you about that also. Wrongly borrowed.
Sir, I remember reading about this one study where since white does not absorb that much heat, they were trying to genetically modify plants into whiter tone
I see.
reduce.
So that they reduce absorbing heat.
Yeah, no,
Don't
reduce
know about
the
it, but yeah,
heat on the
okay.
surface.
Oh, yeah, we'll find out.
I don't know what happened.
Okay,
I'm
good.
reading about it.
Good, yeah. What else? Products. Ah,
So roads are painted black so that
yes.
if they are painted white, then they would reflect light and it would be glaring to the right.
It'll be good, no?
No.
It would be bad. It would be bad.
It'll be bad, is it?
So how
Black
many
is good.
But the land would heat up.
It's fine, sir. Sir, either ways it is heating.
Huh?
Black is radiator also.
But black is radiative also, correct?
Walkways in parks and temples, they have a white coating.
White coating because
Easily
yeah. The other day I was walking in I don't usually go to temple. I'll tell you the reason later. But in the temple, the outer pathway was sometimes white, painted white, sometimes painted black, and I could see so much of difference between the temperature, the white and the black. Just experience it. It's very important for us to experience it. Yeah. Huh? Black? Black body. You mean the black bodies you're talking about? Okay, very good. Which absorbs everything. Okay. Anything else? So it's a hot summer. I hold a
white umbrella? White parasol.
Should it be white umbrella or black umbrella? Then why are you carrying black umbrella? The reason why we are using black umbrella is because Englishmen used black umbrella. The weather was cold over there. But what did we do? So we had to be careful. Very good. Next, shall I go to the next one? Ready? Huh? Okay, here.
Ink pens.
Pens.
Ink
Ink pens.
Oh, ink pens, very good.
Sir, coconut trees. Yeah,
Plants actually, there are two phenomena that occur. Transpiration and chemical reaction. Thermometers to a certain extent, yes. Lamps. Let's see, I'm going to use chocolate as the motivator for this because there is one example. There is one example. I'm going to use Kit Kat, okay. There's one example. If you tell me, I'll give you. Because that will sort of branch up to so many such examples. Blood vessels. No, not really.
Straws.
Huh?
Straws.
Shawl.
Straw.
Straw is actually suction, not capillary action.
Dipping a cloth into water and it rises up, it gets wet even at the top.
Wonderful. Wetting of cloth. What else? Wetting of cloth. Wick. Very good. Go ahead. Wetting of cloth. Wick. Sponge. Very good. See, look at how many solutions come up.
Reverse osmosis in a sense. Reverse osmosis, sir. In a way, because we can have.
Not reverse osmosis. Yeah. Go ahead. Sponge. Wet cloth. A cloth that wets. What else? Wick. Very good. Go ahead. Tissue papers. Right? So many examples where absorption was very important through capillary action. Right? But we forgot it completely. We started thinking about other things. Right? I just wanted to point out because we're creating a habit of looking at a scientific principle and asking what products have this.
Swayam Prabha. Digital India. Educated India.